Welcome to AP Podcast 7.11. This is on electron configuration. And really what it is just a review of the rules on how we do electron configuration, because this has been a review for all my students. So let's look at this first thing, the Aufbau Principle, right there. Okay. Now Aufbau just means filling up. So what that means is that when electrons fill orbitals, they're going to start with the lowest energy level first. So let's look at a simple diagram. If we were to look at, here's the electron configuration for helium, but let's imagine an element with maybe 7 electrons, something like nitrogen. Well, the next electron would go right here. Oops. The next electron would go right here. And then that would be electron 4. And then electron 5, electron 6, electron 7. And again, they're going from the bottom up. That is the Aufbau principle. Now, Hund Rule says that the lowest energy configuration for an atom is one that has a maximum of unpaired electrons in the orbitals. And so what that means as far as us filling up, you'll notice that when I put in the electrons right here in this diagram, I didn't here, let me erase this. Maybe erase this. I didn't go ahead and do this. Put one here and then pair up that one in the orbital. It's not going to work like that. We want the lowest energy state possible. And so the lowest energy state possible is when every orbital has an electron before they are forced to pair up. Okay? So that's Hund's rule. So we've got the Aufbau principle from the bottom top. Hund's rule that says you can every orbital is going to fill with one electron before you pair it up. And then the last one is the Pauli exclusion principle. And this really goes back to our quantum number thing. And here are the 4 quantum numbers that we were looking at before. But the Pauli exclusion principle says that no 2 electrons can have the same 4 quantum numbers. And so that's where we get this rule that we had last year, that an orbital can only have 2 electrons. So in every box in this diagram, the maximum number of arrows we could put is 2. And those are the rules for electron configuration. Now, why is it this is important is because often on an AP test, they will make a statement, ask you which one of those rules it is. So it's really important that you get those 4 down and know which one's which. I know in the past you guys know what the rules are, but you don't necessarily know the name attached. Well, this is one of those situations. All right, and then now the one thing that we didn't really look at last year when we did this stuff, but it is important this year, are the exceptions to the rules. And so if you were to look on the periodic table and you were to see these rows, or I should say this row, this would be the 3rd period, titanium, vanadium, and manganese all have electron configurations that make sense. That's exactly how we would do it. 2, 3, and you would expect chromium to have 4s2, 3d 4, and then you would expect copper to have 4s2, 3d9. Well, it turns out that they don't. If you were to look at the periodic table, it might make sense, because if you look at how many d orbitals, remember there are 5 d orbitals. So in this situation right here, chromium is losing one of its s electrons and giving it to fill its d orbital half full. And then in this situation with copper is losing one of its electrons to fill up its d orbital, and so that gives the atom a little more stability. And I've heard a number of reasons why it might happen, but I think the bottom line is still scientists aren't 100% sure why, other than saying that electron configuration is more stable. So there you have it, a quick podcast on some of the rules. We'll practice a little bit electron configuration, but again, I just want to emphasize it is important that you know which names are associated with which rules. And we'll see you next time.